Hey AP Calcers, Mr. King here. To solve this, you may recall that we separated variables, and as you know, this is a key step in solving a separable differential equation. If you don't have this step, you may be dead in the water. Now, we can write the integral symbols here. You don't have to. We can simply do antiderivatives, but I'm going to put them in anyway. So let's put in the integral symbols. We're anti-differentiating essentially. And when we do this, we get the natural log of 1 plus y, and that's the natural log of absolute value of 1 plus y, and the natural value of the absolute value of x, and then we're going to put a c here, like that. Some of you may not always be putting the absolute value in on these integrals. You must, and we have to see why we can get rid of them eventually, the absolute values, that is. At this point, we can take each side as the exponent, and we're going to take e and raise it to the ln of 1 plus y, absolute value of that, and then the right side is e ln absolute value of x plus c, like that. Now this leads to the absolute value of 1 plus y equals c absolute value of x. Now, the AP grading rubric never showed this step this way. They just wrote 1 plus y equals c absolute value of x. I'm going to show you why they can do that. Clearly, the absolute value of something can equal a constant times the absolute value of something. Both will be positive. What's key here is this. In our particular problem, x can't be 0. Could be negative, could be positive. Doesn't seem like it would matter in this equation that we're looking at. Now at this point though, we're still trying to find c, which is this constant, and to find it we need to pay attention to the initial value we're given, negative 1, 1. So x is negative 1, y is 1. So we're actually on the side where x is less than 0. Okay, if we back up to the other page, and we look at this expression right here, the e to the ln of the absolute value of x plus c, that quantity cannot be anything but positive, which means c to the absolute value of x must be a positive quantity. Okay, so this must be greater than 0. Now, if that's greater than 0, then the absolute value of 1 plus y must also be greater than 0. We're doing some Algebra 1 now, believe it or not. And to solve an inequality like this, we set up two separate inequalities. The first inequality is 1 plus y itself could be greater than 0, or 1 plus y could be less than 0, which leads to two solutions. Y is greater than negative 1, or y is less than negative 1, like that. Now at this point you may be thinking, this is really getting complicated, but wait a second, now this is pretty cool. We go back to the initial value, and what is y? Y is 1, right? Oh, if y is 1, then y must be greater than negative 1. That's where we're interested. So we forget about y being less than negative 1. It's irrelevant to this problem. Okay, now let's put it together. If y is equal to 1 at the initial value, that means that y is greater than negative 1. Okay, we don't need the absolute value on 1 plus y. Think about it. If y is greater than negative 1, well, we just proved it. 1 plus y is positive. So we can say the following. Therefore, 1 plus y is equal to c times the absolute value of x. And now we'll go solve for c. Again, to find c, we have to put in the initial values. That's 1 plus 1 is equal to c times the absolute value of negative 1, which means that 2 equals c, or c equals 2. If c equals 2, we can now write 1 plus y equals 2 absolute value of x, or y equals 2 absolute value of x minus 1. And this looks like it's our solution. But if we look at this solution, x can be anything, can't it? But if we go back to the beginning, x cannot be 0. The differential equation doesn't even exist there. So x equals 0 cannot be part of our solution. And because of that, well, we can mention that right here. Let's just remind ourselves x can't be 0. And that means that this solution can't cross the y-axis. It can't go through the value x equals 0, which means we must limit this solution to the side of the x-axis where the initial condition is, -1, 1. This solution is to the left of the x-axis, which means x must be less than 0. I hope that explanation helps you to understand this one. That's a little bit more intricate than we usually run into, but they can actually be this difficult or even worse, believe me. But this is a good one to have a handle on.